All right, we got another comp LS roller we're going to try to salvage. Stay tuned and we'll get into it. All right, so this one was sent in. It's got, let's see, that one. This is intake. That one, and that one. So all three of those intakes, and then I was looking. Let me get my spectacles. And we'll go over to the computer and look at the lobes. I run it so I could see the lobes, but all the lobes has got a lot of chatter in them, and it was this is the data from comp. So it's a 233, 248, and this is, where did I see it? JHR, I guess. Whoever JHR is, it's the grind number is JHRNA. So whoever JHR is, you don't want to be using these lobes because they're entirely too fast. The comp lobe numbers, a 13041R is the intake. It's absolutely too fast for a street car. Oh yeah, here's the one. So I mean, you can actually see it's beating it up already on that intake. I mean, yeah, well, I mean, like I say, that's probably the worst one. And then this one, I mean, it ain't real bad. It looks worse than it is, but as far as like depth, it ain't real. But you know, but I mean, it's getting them. I mean, it's getting them. So you know, and we talked about some of this in the in the Q&A when we was at PERI, and then we hit a little bit on it in the follow-up video about the Q&A. You know, with hydraulic stuff, I mean, even solid stuff too, the same thing will happen. You can only go so fast in a given platform, and you've got to be able to, you know, ever how fast you're going, the rest of the components have to be happy with that system. I mean, you can't just put this super aggressive lobe in, you know, whatever, and again, I don't have a clue if this thing is I'm gonna bet it's a LS3, and it's probably got a heavy intake valve, and it's fast, and it's just creating a bunch of problems altogether. But I've got it, so we've got some of our DPX series lobes that are, the intake is the same duration. The exhaust is, I think it was 2 degrees smaller. It was the closest thing I had to put it back to, you know, where it's at. But it's a little goofy because it's a 113 plus nothing. So depending on the intake valve closing point and what they're doing with it, that's probably a pretty late closing number. We'll look at what the actual number is, but for a NA, because it says the grind is whatever NA, so I'm assuming this was designed or, you know, selected for a no power adder deal. So to have a intake valve closing that late is a little weird. So it could probably benefit from putting it in, you know, plus 3 or 4 or something. But again, we'll look at that number. But so the masters are loaded. It's in the machine. I've swept it in and verified the intake center line, and it should be 113. And I swept it in, and we're like 112. Yeah, 112 and a half. So that's all good. So we're gonna fire this thing up and I'm gonna just touch off on maybe get the first one touched up and just let you see that. And then we'll cut and go over to the computer and look at these lobes, and then we'll look at my lobes after we finish grinding it. So we just touched over here, so we're gonna push her back just a little bit. There we go. Yeah, and I thought it was odd when they called me about could we fix it. They said they called the manufacturer and sent them pictures, and the manufacturer told them that it was already under the heat treat and they couldn't fix it. And so if 10 thousandths wear is already under the heat treat, it was already under the heat treat when it left the manufacturer. So that's cleaned up. We're gonna run down here on this ugly one, and we're gonna use the ugly one to set our height, how much we got to take off. So we'll get this one, and then we'll come back. We'll let this set our height, what we got to go to. What is my, here we go. 225. 225. Yeah, this is probably I guess this is probably the worst one, maybe. I'm gonna just keep up with how much we take off of it. Oh, we're getting close. That's it, ain't it? Yep, that's it. So that's 20 thousandths exactly. So, I mean, that's total 20 thousandths now. So it didn't take but 10 off top, 10 off the bottom, right? So if that's under the heat treat, we had a problem before we started. So, I mean, some stuff you can't fix for sure, but this ain't one of them. I mean, this is a straightforward regrind, no issue at all. So now that we got our stop set, we know where we need to be, we'll make all the intakes that hill to toe, and then we'll come over and some of the exhaust are not hurt, and I'm gonna show you why the exhaust ain't hurt and the intake is right here in just a minute. Show them that. So I mean, you can see she's all cleaned up. And like I say, that was exactly 20 total overall. So what we'll do is I'm gonna what I was saying about the exhaust. So there's a couple. Let's see, like this one's a little bit ugly. This one's got like some trash got in the wheel on the lifter and run around it. So we're just gonna touch all these exhausts too. So we'll bring all the intakes to that height, and then we'll just clean up the exhaust. And again, we ain't taking enough to amount to nothing either way anyhow. So, and we'll get all them cleaned up, and then what I'll do is I'm gonna just, I'll run it with these new lobes in the Cam Doctor, and then we'll look at all 4 lobes, and I'll show you why these intakes are just a little fast for probably this application, and then we'll look at the new lobes and all of that. So we'll be right back. So the cam's done, it's all nice and shiny, and everybody's happy. So let me start this screen recorder. All right, so these are the original lobes. This is the velocity curve. So let me bring this over. All right, so that's at 4 thousandths lift, which is usually where we check this stuff at the lobe. So you can see up here the velocity is 1.1, well, 1 thousandths and 1/10 and a half, but the acceleration is 2/10, which is really, really fast for a hydraulic. And that's what gets you in trouble. And then even on the closing side, it's a little high, which is another problem with a hydraulic, because you'll bounce it off the seat. So it's still at 1/10/6. So usually, like on the closing side, about 1/10, maybe a tick over 1/10 is where you see most stuff that's happy. But that's a little, but the exhaust side's fine. It was no problem. So let me turn this off. All right, so this is the lobe we put on it. I think we can overlay, let me overlay it. So you can see how straight the angle is on the velocity curve on the original lobe, and how much less angle is on the velocity curve, and even just the overall height. So I think this one went to like 8.6, and I think this one goes to like 7.8 or 7.9. It's a little bit less velocity, but let me turn this one back off. So on this one, since we're over here on the closing side, we'll just look at the closing side. Oh. All right, so it's 7/10 and 1/10 and 3. So it's, I mean, it's still a little bit fast, but for sure it's way slower than the original one. And then we come back over here on the opening side. All right, and then we just under 1/1000ths on velocity and not quite 1/10 and a half on acceleration. So that's much better. It's still aggressive. I mean, you know, but it's not crazy stuff. So, and like I say again, the exhaust was fine. It didn't have an issue at all. So, and we put a similar exhaust lobe on it, but it had 3 degrees less duration, because that's just the closest thing I had to make all that work out. And we added the original, let me see, the original exhaust lobe was 351. Yeah, I think it was 351 lift, and we put a 365. So now the intake and the exhaust are 365. So before it was 365 and 351, so we just evened up that. And like I say, we still didn't take but 20 thousandths off of it. So that all worked out. And but like I say, just stuff like that, sometimes it's, I mean, you just can't know. I think this thing had a 50 intensity, which is really fast. And when I seen that, I felt confident that it was probably gonna be a little spicy. And so I think the lobe I put on it's like a 53 or a 54 intensity. So that'll make it better, and it should live without any trouble. We're gonna sell him some GM OEM lifters, and it should go back together and be fine. But anyway, I thought that that would be interesting just to see, you know, when you got a problem with a cam, it's like, why did my cam die? You know, did I do something wrong, or was it just bad parts? And you know, not all the time is that the case. Sometimes it's just, you know, the lobe design was a little too aggressive for the application. So anyway, thanks so much. Like, share, subscribe, and we'll see you on the next one.